Hello students, now in class 12th I have told you about the transistor, and now I will take that the symbol of the transistor, and I have told you this PNP and NP and two types of transistor are there. And now today we will see the configuration of the transistor. Configuration of transistor. As you know that transistor is the three-terminal device, the emitter, base and the collector. So that how to find that which will be the emitter, which will be the base and which will be the collector. Then just to have to this one that symbol. This is like this. It has three terminals. Then this part is have a symbol here, this. You can see here, and this shows the emitter. Then this is the base, this is the collector. This is clear. So that this point mark shows the emitter. This is the emitter. This is base and this is the collector. The point mark this shows emitter and remaining terminals are base and collector respectively. There are three configurations of transistor. Number one, the common base configuration. Common base configuration. Second, common emitter configuration. And third, common collector configuration. Common base configuration, common emitter configuration and common collector configuration. Now I will draw the circuit diagram of all these three types of the configurations. This is emitter. This is base. This is collector. And this is earthed. This is positive, negative. This is negative and positive. Similarly, in case of NPN, this is like this. This is emitter, this is base, and this is collector. So here now this is for NPN, this is a PNP. Common base. This is NPN. Common base. And this part is arched like this. So this is your positive and this is now negative. Now in this part the current is like this. This goes and this is your IE, this is IB, and this is current IC. This is IC. Here the current is like this. This is IE and this is IC and negative. So this will be like this. This is these two will meet. So this is the current, your this is IB. This is like this. So this IC is like this. This is IB, then this is now IB like this. IB. So this is PNP and NPN common base. This is the common base. Configuration. Now then we have the common emitter configuration. Now in common emitter is what that if we have this is the diode transistor, this is the base, and here we have this. This is the emitter E. this. Here the current is this IE, P and P. This is IE. This is point C, the collector, and the current here, this will be like this. This is IB, and that here we will have this negative and positive like this, and this part is earthed. This is negative, this is now positive, so current is basically this is your IC. This is PNP, PNP transistor. And we have this is now base, this is emitter, and here this is collector. Here we have this NP, so this is now your P, like this, positive. The current here, this IE, and here is current like this, IB, and this we have NPN, so this is positive. This is positive and negative. This current is IC, and this part is earthed like this. So this is NPN transistor. This is NP. So this is the common emitter configuration of PNP transistor and NPN transistor. And now common collector. Common collector. Configuration. Now in common collector, we are having to this one, this is the common collector, this is emitter, this is now collector, this is now base. Now here this is PNP, N, like this, and here we have This is positive, this is negative. So here the current is like this. This is IE. And here the current is like this. This is IC. And this will be your IB. This is PNP. PNP transistor. PNP transistor. Now we have this NPN. Now this is the current. NP. This is NP, P, this is not positive. And here this is the E, this is your C, this is your B. So here we have this this is positive, so this IC and IB, we to say IC. IC, that will be downward. This is IC and IB similar to this one. And this is your positive to negative, so this will flow like this. And here we have this to be now the negative positive, and here we will have the negative positive. This is the configuration here, and negative positive. See here the current, this is IE, and this is the current IC, and that's the current here. This will be like this. This is your IB. So this is NPN transistor. NPN transistor. So these are the three types of configurations that you have here. And now you see that this is the common part. So common part is always Earth. The common part is Earth. Common part of transistor. Earth. As it is to be taken at 0 potential. So this is Earth. This is not taken at 0. This is not 0. So all the common parts are to have the zero potential across this point, at this point. Similarly at this point B. And you see in all these configurations there are two kinds of circuits. Just you see the left part of the common. This is now common, then this left part, this is now right part, this is left, this is right. Similarly here, this is left part, this is right part, left part and right part. So it means that it has two circuits. One the input circuit and second the output circuit. So this is called the input circuit, this is called output circuit. This is input, this is output, this is input, this is output, this is input, this is output. So here this is input and this is output, this is input, this is output. So we have two circuits. In all configurations there are two circuits. On the left of the common part, number one, input circuit. And it is on left of common. Part, and output it is on the right of the common part. Output circuit, it is on right side of common part. So actually all these configurations have that we have to draw the characteristics of the transistor. Characteristic curves of transistor. Since there are two circuits in this configuration, so we have two kinds of characteristic curves. There are two types of characteristic curves. Characteristic curves. One is input characteristic curve. Input characteristic. Now in this circuits, in this characteristic curves, the output voltage keeping output voltage constant, the curve is drawn between input current and voltage. What we do, that output voltage is kept constant. Keeping output voltage constant, the curve is drawn between the input current and the voltage. And now second type of characteristic curve, the output characteristic curves. Output characteristic curves. This is the input characteristic curve. This is the output characteristic curve. So here what we do, that keeping input current constant, the curve is drawn between output current and voltage. So for input, the output voltage is kept constant, and for output, the input current is kept constant, and then the curve is drawn between the input current and voltage and output current and voltage. So thus we get two kinds of the characteristic curves. So first we are taking here the common base characteristic curves. Common base transistor characteristic curves that I take here. Now first I take the circuit diagram of this one. This is suppose your here I am taking the P and P. This is E, here this is now B, and this is now C. Now here P is now positive, positive and negative. This is now rheostat RH, and to measure the voltage, here a potential. This is, and here we have This is P and P. And here we have the and for this we have an ammeter. This is now voltmeter. This is ammeter, milliammeter. Milliammeter. Here the current is like this. This is IC. So here we will have this negative and this is now positive, and this is your positive, this is negative. This is negative and this is now positive. So this voltage equals to this one. This is called VEB. VEB. This is your VCB. And this we name, this is now V. This is given the name VBD, and this is given the name VCC. So here this voltmeter will show you this the deflection, and that for the current we can have to measure this one. This is your milliammeter, like this. And that positive to negative. So the potential difference and here the current that will be like this. This is now your IC that we do not take it. This we earth. We are not showing to this one. So this is your PNP transistor. This is the circuit diagram to draw the characteristic curves of the common base transistor. It is circuit diagram of common base PNP transistor. So the input characteristic curves, input characteristic curves. Now what we have, this VCV is kept constant. VCV. The output voltage VCV is kept constant. The curve is drawn between emitter current emitter current. IE and emitter base VEV, meter base voltage. And these curves are like this. This is your IE. This is in milliampere. And here we have the VEB on this side, and we get the curves like this. So this is when this VCB is kept constant. So suppose VCB is at your 0 voltage and then it is minus 5 volts. VCB equal to 0 voltage. Here VCB equal to 5 volts. So this is not 0. So now you see that these curves are similar to the forward bias junction diode curves. These curves are similar to forward bias characteristic curves of junction diode. So you see that the curves starts from origin. This is now from 0, and you can see that as VEB increases, then the current increases. So we have the dynamic resistance. Dynamic resistance and dynamic resistance, this is your R. Input, this is taken input delta VEB upon delta IE, and here we keep this VCB constant. So we take R of the curve and then find the slope, and that will give you this value, and this is now your dynamic resistance curves. And now we have the output resistance curves. Output characteristic curves. And what we do here, the emitter current IE is kept constant, and curve is drawn between the collector current IC and collector base voltage, collector base voltage VCB, and these curves are like this. Here we take this IC in milliampere, and this is now your VCB, like this, and we are getting the curve like this. Here this we can have this IE to be very small value. This suppose here this IE equal to 0, IE equal to 2 milliampere, IE equal to 4 milliampere. So you see that all the curves starts from the origin. This is you take the origin here, 0. Now all curves start from origin, and you see that initially when VCB is increased, the IC increases and becomes saturated. You see that these curves are parallel to this, so this IC is not increasing. Initially there is increase, and then it becomes constant. This is also constant, this is also constant. So this is a saturated current. Saturated current. Saturated current. And now we have the dynamic resistance. Dynamic resistance R0. This is taking the output. We are taking the output resistance curve. So we have this R0. This is now your delta VCB upon delta IC. Keeping this IE constant. So choose either of the curve and find this resistance. And here we have a one more coefficient, that is the current gain. Current gain or amplification. Amplification of current. This is your keeping VCB constant, the ratio of collector current to corresponding emitter current is called current gain. Current gain or current amplification. Denoted by alpha. So this alpha equal to IC upon IE, and this is when this VCB constant. So you can see, since IC is less than IE, therefore alpha is less than 1. Though they are of the similar amplitude, approximately of the same amplitude, but even this IC is less than IE. So value of alpha, that varies from 0.9 to 0.99, but this is not equal to 1. The value of alpha varies from 0.9 to 0.9. This is the dimensionless constant. Alpha is dimensionless. So it has no unit at all. And also I tell you that your classes for 11, 12th and that of the NEET online classes from June 1st, 2021. This is now your 11th, 12th and NEET. And in NEET we have two. This is now crash course 2021 and the regular class 2022. So you can contact me 7014734 5. Contact and get your registration because the time is very less and moreover we are having a very limited seats. So please, if you like to join me, then call and get your registration as soon as possible. Thank you very much.